Hello, my name is Talha ERASLAN and I'm the leader of Team 4. In this part, I will summarize our team roles, customer needs, objectives, research survey, and how our design satisfies the main requirements. At the beginning, we divided the tasks according to the work breakdown structure. I followed the schedule, organized meetings, supported testing, and contributed the cost analysis. John designed the system architecture, Onur developed the smartphone application and Bluetooth communication, and Berkay worked on the hardware structure, sensors, servo motors, and stable power connections. Based on the customer needs and problem statement, we defined our main criteria at low cost, lightweight design, high alignment efficiency, and smartphone control. According to these criteria, we developed Novaxis as an affordable, portable, and smart solar tracking system. In this way, our final design directly responds to problem identified at the beginning of the project. From these needs, we created objectives such as low cost, low weight, smart control, 50-watt output, and high efficiency. Low cost and high efficiency were our highest priorities. In this research survey, we compared similar systems and positioned Novaxis as a low-cost, portable, smartphone controlled, and dual-axis solar tracker. Finally, our design meets the measurable requirements. The total cost is $96. The weight is under 5 kilograms, response time is under 2 seconds, and alignment efficiency is at least 90%. Therefore, Novaxis satisfies the main customer needs and technical requirements.
Hello, my name is Can Kıraç ÖNDER, and in this part, I will explain our concept evaluation, level 0 design, and level 1 design of the Novaxis Smart Solar Tracking System. First, we determined our final system concept by comparing alternatives according to key criteria such as cost, portability, tracking accuracy, and smartphone control. Based on this evolution, ESP32, Bluetooth communication, dual axis tracking, servo motors, and 4 LDR sensor array were selected as the most suitable options for our project. Bluetooth communication was preferred because it provides a lower cost and simpler solution for smartphone-based control compared to using additional external communication modules. In the level 0 design, the system is represented as a single black box model. The main inputs are sunlight, user comments, and power inputs. The main outputs are optimized panel position, remote monitoring data, and electrical power output. This level gives an overall view of system without showing internal module details. In the level 1 design, the system is divided into 6 main modules: sensor, control, communication, motor tracking, solar panel, and power. The sensor module detects sunlight direction and sends data to control module. The control module processes sensor data and user commands to determine the required panel movement. Users can select automatic tracking or manual control through the smartphone application. The communication module handles data exchange. The motor module moves the panel. The solar panel generates electrical output, and the power module supplies regulated power to the system.
Hello, I'm Onur KARAKOÇ, the software engineer of the Novaxis project. Let's look at the level 2 design of our system. Raw solar energy enters the power management unit, which safely provides power to all components. The microcontroller acts as our brain. It reads light intensity from the LDR sensors and sends PWM control signals to the servo motors to align the panel. At the same time, it connects wirelessly with our smartphone app for remote monitoring and control. Next, we have our behavioral models. On the left is our state machine. The system normally runs in auto tracking mode, but it can switch to manual mode if it receives a smartphone command, or night mode to sleep and save power when it gets dark. On the right, you can see our tracking logic. It calculates the light difference between the sensors. If the error is above a certain threshold, it moves the servos toward the higher light side. Finally, here is our detailed test plans. We start with unit tests to check individual components like the sensor array and servo motors. Then module and integration tests make sure our dual axis algorithm, power management, and Bluetooth interface work together smoothly. Lastly, system tests confirm our final goals, achieving high tracking accuracy, keeping the total weight strictly under 5 kilograms, and successfully generating 50 watts of power.
Hello, my name is Berkay DEMİR, and in this part, I will present our risk analysis, Gantt diagram, cost analysis, break-even analysis, and sustainability considerations. In the risk analysis matrix, we considered possible technical risks and developed alternative plans for each case. The main risks are LDR sensor failure, communication drop, power instability, and servo motor instability. If the LDR sensor fails due to weather conditions, the system can switch to software-based astronomical time tracking. Similarly, if Bluetooth communication drops, the system can continue in automatic tracking mode until the connection is restored. For power instability, voltage regulation and external DC support can be used. while mechanical instability can be reduced by reinforcing the frame or locking the panel in a safe position. The Gantt diagram shows our timeline from the team organization to final video preparation. Key tasks such as component selection, Bluetooth integration, testing, and cost analysis were planned step by step. For cost analysis, the total prototype cost was calculated as $96. This supports the low-cost design target and keeps the system under the $100 budget. According to the break-even analysis, if we set the selling price at $140, the break-even point is approximately 273 units. After this point, the product starts generating profit. Economically, Novaxis supports our low-cost target by improving efficiency. For sustainability and reliability, we focused on clean energy, lightweight structure, recyclable materials, reduced energy loss, and stable auto operation. Thank you for your listening. Please contact us via email for any questions.